Okay, so here let's talk about the third visualization strategy. Okay, is to if you have too many items or if you have too many attributes, you can just reduce item or attribute. It means you just show a portion of the items or a portion of the attribute. Okay, so we have many different strategies. Okay, and this is just a list of them. And right now we are here. Okay, so to just show a portion of the data, of course, all you have to do is to filter out something. Okay, it means we want to eliminate or remove, okay, some items or some attribute by some condition, and this will make the visual exploration is more effective, or you can say it's easier for you to have a visual design. Okay, one example is like if your data set had too many attribute, right? Attribute is equal to a dimensionality. So, and usually each attribute we need at least one visual channel to represent it. But if you have a lot of attribute, we do not have enough visual channel to use. So, to reasonably reduce the attribute items, it also help you to have a good or easier to have your visual design. Okay. So but to filter out some information, remove some information, we have some challenge. Okay. One challenge is we want to filter out some information, but we don't want to have the information lost. Okay. Okay, this is not possible, but how I say is probably we can change this to without important information loss. Okay, we still want the user can observe some phenomena in the data instead of just you remove something and he cannot find anything. Okay, no, that is not what we want. Okay, so of course we want to support the effective and dynamic query. Okay, so this means like because filter out it means give some condition. Give some condition is also equal to query. So usually this is dynamic. Okay, it's usually this is not a case that when you design it, you just select some attributes that I want to remove it, then just show them down. Okay, no. Usually this filter is going to help the user to do the exploration. Okay, just I filter out something, maybe I see some patterns, so I have some idea about data, I want to verify my hypothesis, I filter out the other set of the things. Okay, then I find some pattern, it may be verify my hypothesis or not. Okay, so it's dynamic, so you have to support some effective dynamic query, okay, for filter out. Okay, and do it efficiently. Okay, yeah, because those filter out, if your data set is huge, if your visualization is complicated, maybe it's slow, you need computational power. So how to do it efficiently, use the right tool, that's also a problem. Okay, then here is just an example, it's a fun finder. It's an example about filter out. Okay, and here it shows advantage of filter out. Okay, here the first thing we just look at the data. Okay, in this data I just every data point here. Okay, no matter what color it is the this one is the popularity of a movie, and this one is the year of the movie released. So you can see there's so many year, so many popularity, we have so many movie here, we just cannot put more information, right? But what we can do is sometimes we don't want to see all of them, maybe I just want to see some we can give some condition to filter out it. For example, we can say I only want to see some for example higher popularity movie, and also in some in like a 10-year span or 10-year range. Okay, so then we will filter out much fewer movies, and it's not just filter out much fewer movies so user can see all of them. No, it also means in the visual design we can put more information into it. Okay, like right now here, okay, here is just like a lot of dot here. What we only can see is just, if you can see, like a distribution of those movie, right? When it's more close to now, okay, we have more movie name, maybe that's what we can see. But here, okay, we can put maybe the name of the movie, okay, with the dots, then you can get more information. Okay, maybe you recognize some movies, or you know, okay, and you know it's how popular it is. And also we can have more interaction, when you mouse, okay, move to hover on some point, right? It can pop out a small window and give you more information. Okay. Okay, then, and the other one is, okay, here is just a filter item example. Then one skill here is the Sandy widget. Okay, it means after after you show the how to say, after you show a portion of the data, you probably want to pop out. Not always, but this is just one way to do. You just want to pop out our small widget, and this small widget has some summarization of the data you have. Okay, so this can give the user the concept about, okay, after it gives some condition, filter out a lot of data, you just see a subset of the data, and what is the overview? What is the overview of this subset of data? Okay, for example, after you filled out something, you can have a small widget shows the distribution of the remaining data. Okay, and you probably can also show okay, the rest of data have 4 different category, okay, or more different categories, something like that. And also on this small widget, you do not only be able to give the a summarization of the data you show right now. You can also let user to have interaction or query or selection or add more condition on this widget. Okay, like right now, here it show we have 4 type of categories. After we filled out data, it maybe show something here. And you can say, okay, maybe I want to filter out more. You can just let the user uncheck one of them. Okay, something like that. Okay, you can also have more query condition on this widget. Okay, so what we say here, okay, right, is about the item, filter item, right? And the other way is filter attribute, right? Okay, so if it's an Excel file, again, this is attribute, okay, color is attribute, and this is item, row is item, or data point. So we can also have the attribute filter. Okay, what it means, because sometimes we have too many attributes, we just do not have the space or pixels to show all of them, or it's too many, even show all of them, I just have no idea what happened. Okay, so it means the attribute filter is a filter some attribute is necessary. Okay, so so for example, this one, okay, it means the minion row data is not what I will say, but just an example, if each one is the the ability of a student. Okay, like you may often see this kind of plot, right? Okay, let me say this one is a math, this one is Chinese, okay, this one is physics, chemistry, and programming, and whatever we have, history, right? So then you can say like maybe one student is ability something like this one. Okay, so it means it is very bad at the history, but rest of them are good. Okay, so we can think this one is something like this one. Of course, this example is simple. We just have like 6 attributes, but we probably in some data set we probably have more like 200. So for 200, you may get something like this one. Okay, you just have no idea what happened. This is the student 1, this is student 2, this is student 3. You just no idea what happened there. Okay, so 2 things you can do. One is attribute filter, but how to filter the attribute? Okay, you just do not randomly filter the attribute, right? You usually don't just throw a dice and say I want to filter out this one. So all you have to do is one way. Okay, just one way. It's an example. It's not a rule. Okay, one way is like you just calculate and find which attributes are similar, which attributes their similarity are high. Okay, and you do not have to show all of them, right? You just use one to represent those attributes. It's something like just cluster, doing the cluster across the attributes. Okay, then after that, you just use one to represent them. Okay, then you will become like more spots and you can see them. And the other one is like you can order the attribute. Okay, you can even you have the multiple group of attribute and each group you just use one attribute to represent them. But between the clusters, attribute cluster, maybe like this one is more close, this two is more far away. You can use this information to reorder those selected attribute. Then it can give you more information. For example, like this one, maybe I want to reorder it like I want to put the math and the physics together, and then maybe chemistry and programming language. Then in the end, it's history. Okay, you have something like if they are more close. Okay, here just I just make out this. Okay, but usually this attribute order probably just like determined by you have to analyze the data. Okay, some algorithm to analyze the data to select or find or calculate high correlation attributes. Okay. Let's see. Okay, aggregation. Okay, so to reduce the data set you have to show, to reduce the data point you have to show. The other way is to aggregate data. Okay, aggregate data is many different ways. Like you can just depend on the data points to cluster data. If these 2 data points are very similar, right? Okay, then you just cluster them together. Then you just use one to represent them. And the other way is like some like a statistical, okay, aggregation. Okay, like probably you have some prior knowledge to separate, to divide the whole data set into multiple small group. And each group, okay, maybe easier way is like we have multiple class A, B, C, D. Okay, and each classroom has many students. Then I want to say, okay, in total we have 400. I don't want to show 400 scores. Okay, but we can use like average. Okay, to show them. It will give me some concept but might be meaningful. It might be still meaningful. Okay, but we have more like a minima, maxima, count some. we have many basic aggregation or statistical aggregation. And the challenge is when we select which operator we want to use to aggregate those information, we have to be careful about that. We don't want to eliminate the interesting information. What I'm talking about, sometimes we may think the average present the data well, present a group of data well. If it's not enough, we can use like a sigma. Okay, we can use a standard deviation to be additional information to understand the overall, the overview or big picture of the data. Okay, but sometimes you really eliminate some interesting information. Like if your data tell you that this is your mean and this is your standard deviation, this is standard deviation. It is possible that, okay, this is your data distribution, but probably this is your data distribution. Okay, I believe you may say this data distribution is quite different. There's one peak and the two peak. Okay, but if you just use some basic aggregation like just average to show it, okay, you will miss those more detailed information. So you have to be, when you use aggregation to have more space to do a visualization, you also have to think about or be careful about, do I miss some information the user may interested in? Okay. Histogram, I believe everyone know what histogram is. Okay, this is just, histogram is also one kind of the aggregation. Okay, because it will become a distribution. Like if we want to have if we have a data point about we have another cat and each cat has weight, and each cat has a weight, right? Then how can we show or represent this group of cats, right? We can use the distribution. Okay, maybe we just have the bins. Okay, each bin is the range of the cat's weight. Okay, then the y-axis is the count, right? In between this weight, how many cats is in between these weights? Okay, so it's a histogram. And usually we use rectilinear representation to show the histogram. Okay, so this is aggregation, right? Because in the beginning, our data is like we have cat 1, okay, and its weight is 2.5. Cat 2, its weight is 5. Cat 3, its weight is 3. But after this aggregation is totally different, different type of data, right? It becomes something like between 5 to 10, we have 3 cats. 10 to 15 pounds, we have 5 cats. Like this, it's just become different, but it might be meaningful. Okay, so or even maybe more useful or better for some analysis task. So sometimes we want to transfer our data to this aggregation to visualize the data. Here, one thing I want to say is often we may think the histogram and the bar chart are the same. Okay, sometimes we say bar chart and we say histogram, but no, that's different. Okay, histogram is like a aggregation from a raw data, and if we say bar chart, usually just a raw data. Okay, for example, to remember in the D3 tutorial, we have an example is the we have some cities, right? Like New York, LA, right? Taiwan. No Taiwan in that example, but fine. Right? Or like Columbus. Okay, and it has the you have a population, right? And we just use the bar. We just use the bar chart to show the population. Remember? Okay, this is bar chart because it's raw data. It's the mapping between it's the data point. I just directly show a data point. It's the city name and its population. That's all. It's not histogram, okay, because there is no statistical meaning here. How can I convert this to histogram? For example, might be I can let me think an example like okay, I can convert to a histogram. Then maybe the bin is divided by, okay, this is not a good example, but maybe the bin is divided by like a different region in United States, okay, like here, right? No, what I'm talking about, no, the better example is the bin can be like the population, right? Like from 1 million to 2 million. This bin is 2 million to 3 million. This bin is 3 million to 4 million. Then this is also count. Okay, the y of a histogram is always count. So maybe then I can say like how many city their population is in between 1 and the 2, 1 to 2 million. How many city, okay, their population is in between 2 million, 3 million, and this and so on. Okay, and this is a histogram, but this is bar chart. That's the differences. Okay, so I think we can quickly go through this one. Okay, box plot. Okay, box plot is also aggregation for visualization. I believe everyone have a sense about this one. It will show the range between 25% to 75% points, and there is a bar at the middle to show the median, and probably show the maximum value and the minimum value. And also, besides the maximum value and the minimum value, you have some rule to identify some outliers. Okay, but usually in most of the box plot, people don't plot outlier. Okay, and this is a more advanced box plot. Okay, this is just like use the shape. Okay, the shape here is always a rectangle, right? Here you just use the shape here to let you know the distribution of the data in between 25% to 75% points. And this is the other example of the solar plot. Okay, solar plot is like aggregation according to the label. Okay, when I'm talking about label, for example, this one is the Ko-Chih price. Okay, and here, sorry, from here. Okay, this is the days of 1 year maybe. Okay, then this is a Ko-Chih price. Okay, sorry, the number of Ko-Chih they sold. What I'm talking about, the number of Ko-Chih they sold. So we can see they sold more and more Ko-Chis across the time, right? And so this is find the label. And probably outside of it, you can have the other circle. Then you have some number here. You probably aggregate, for example, like a season. Okay, so this is a spring season. This is a summer season. This is autumn, and this is a winter season. And how many Ko-Chih they sold, like that. So it's like then this one, the outer one is maybe the course label. Okay, and this solar plot can show different label for you. And if you go to outside, and outside is a course label, you will aggregate the information inside, become what it have to plot at the outside. Or like hierarchical parallel coordinate plot. This is just okay. Without talking about a hierarchical, I probably never talk about a parallel coordinate plot, but I believe we will have it later. Parallel coordinate plot is something like okay, it's very good to use to visualize multivariant, okay, multi-attribute data set. Okay, you can see the correlation between the attribute. Okay, you can also see a distribution on the attributes. So for example, like use the previous example we have, the score. Okay, the math, history, physics, chemistry. Okay, this example. Okay, without talking about the hierarchical, if we have 6, right? We have 6 attribute like math, physics, chemistry, programming language, how we have history. So then at the bottom maybe like score is low, at the top score is high, right? Then each polyline is the a student. Okay, like one student is the math score is here, physics score is here, then chemistry score is here, programming language score is here, history is here. Okay, then one student maybe is score is here, a very good student or a bad student, right? Then if you have a lot, of course cannot be too many, like you have like 200 students, probably plot all of them, you can see the correlation between like two attribute, okay, or two subject. Like you will see a lot of students just if he has like a high math score, you may have like a high physics score, like that one. You will see many things like this one. And the last, the cross line, right? It means these two attributes have a high correlation. Or maybe between history and the program language, you may see a lot of if you see a lot of cross line, it means these two attributes have like a negative correlation. It can help you to find those things. Okay, so this is a parallel coordinate. But here is just say here we are not talking about the fundamental parallel coordinate. We are talking about the hierarchical parallel coordinate. It means it aggregate something. Okay, aggregate something. This means like because if we have a lot of line here, we probably cannot see all of them clearly, and maybe if they are too many, we just cannot see anything. So you probably want to group them by category if they have category. Like here we maybe have like 200 students, but maybe it's like it's across 4 different class. Okay, then maybe for one class, okay, we just represent it by yellow. The other class we will represent by green. The other one will represent by purple. Then each one, like for example, like a green one, okay, you will have a band. Okay, you will have a band of the data, and this one can give you some sense about what is the mean of this class, okay, across all the different subjects, and the max value and the minimum value of this class. Okay, he does not just directly plot all the lines, but he just calculated the mean and the maximum value of the category, okay, and show those like statistical values. Okay, the other attribute aggregation is the dimensionality reduction. Okay, if you don't know what is dimensionality reduction, just think about PCA. I believe almost everyone know what is PCA. Okay, just have a data point is if it's a long vector. Okay, it's in high dimension, in the high dimensional space. Okay, then we can have some algorithm to project those high dimensional data point into 2D, maybe 3D, maybe 2D, whatever, depending on what you want. This is one way to reduce the attribute. And the goal of this strategy, or the goal of this algorithm, is to preserve the meaningful structure in the data, even we project it into a lower dimensional space. What I say, for example, if in high dimensional space, if in a high dimensional space, the data point A and the data point B, they are very far away, but data point A and the data point C is very close to each other. After you do the projection to the lower dimensional space, we still want to see something like this, like A and the B are very far away, but A and the C is close. Okay, you can preserve the structure of your data even you project to 2D. Then we can use a 2D image to imagine the structure of data in a high dimensional space. Okay, then okay, this is just the other type. Okay, or we say just the other example. Okay, this is the other example to have the attribute reduction. Okay, have an attribute reduction. Yes, so like it's like called document collection. Okay, it's like transfer a document into a bag of war. Okay, what this means, like if you have a article, then you just select some common, or you just select some popular vocabulary, then you just count like this one in this article, it appear for how many times, tool for 10 times, filter for 25 times. Okay, then you will become something like a histogram. Of course, clearly, this one, the dimensionality here must be less than the raw data, okay, the original article, because if the original article has 2,000 words, the dimensionality might be just 2,000, it's in a 2,000 dimensional space, right? So this is kind of like a dimension reduction, okay, or attribute reduction. So when we do the dimensionality reduction, so usually we probably have like multiple steps. Okay, the first step is our data is in high dimensional, and we probably want to find some algorithm to reasonably project into the low dimensional space. Okay, usually it's 2D for visualization. So after we finish this transformation and get this one, okay, this one and this one is the same, we probably want to have the visualization. Okay, this part is not visualization. Okay, it's just like something like a pre-process before the visual design. But then after we have this one, our next goal is to visualize it. Okay, maybe you want to have the scatter plot, and then maybe you want to use some color or some shape to highlight some data point if they are belong to the same category. Okay, then after that you probably want to have some interaction for each data point or some category, give some annotation or give them more information about it. This can help the user to imagine the original high dimensional data, or easier to understand the original high dimensional data. Okay, then to display the dimensionality reduction result, the easiest way is just like a scatter plot. Okay, like for example, if you use MDS, its algorithm, we will talk about this later. It's a multi-dimensional scaling, it's called multi-dimensional scaling algorithm. Okay, you just project the high dimensional space to low dimension, and if you set it to project to 2D space, and you can just use like a scatter plot to plot it. Okay, or after you reduce the dimensionality, like for example, original data is like 100 dimension, 100 dimension, but you reduce it to like maybe just 6. Okay, 6 you still cannot use this 2D plot. Okay, but probably you can use some like a scatter matrix. Okay, scatter matrix is something like this. Okay, you can have, if you reduce to 4, okay, you can have so many matrix plot. Okay, like this one is A. Okay, maybe after reduce it to 4 is 4 remain attributes A B C D is A B C D is A B C D. Then you can plot. You can plot the data between A and A. Usually, A and A usually is like a strong positive correlation. Okay, so A and B and C, you can just plot all and put all of them together. It's called scatter plot matrix. And the other thing is after we reduce to the low dimensional data, but what the user really want to explore is the high dimensional data. So you usually need to design some way to help the user to see the high dimensional data. For example, like probably you just select this data point, you just pop out a window and show all the detail of this data point. Okay, then this is the information in a high dimensional space, right? Or you just select a group of them. Okay, maybe user can have some tool to select a group of them. Then you can use maybe parallel coordinate plot. Okay, at least you can show more than 2 dimensional, more than 2 dimension. So then this one can give you some overview of this group of data. Okay, so this is some skill of the attribute item reduction. Alright, I think that's all.